All right, good morning. Let's review the greenhouse effect. First thing I want to remind you guys is the greenhouse effect has always been part of the Earth's atmosphere. There have been gases in the Earth's atmosphere that have contributed to the greenhouse effect and actually made Earth livable. Without the greenhouse effect, Earth would not be livable. We wouldn't have had life on Earth in the first place because it would be too cold. So some greenhouse effect is necessary. And what happens is the sunlight um, travels through space, getting to the outer atmosphere of Earth. Now, some of that radiation from the sun, some of that sunlight, is immediately reflected off the upper layers of the atmosphere. Some of it bounces through lower layers of the atmosphere, and some hits the Earth's surface and gets reflected back off into space. A lot of this solar radiation, however, hits the Earth's surface and warms the Earth's surface. So it's absorbed by the Earth's surface and then it's re-released as infrared radiation. The infrared radiation is what we think of as heat. So when I say it warms the Earth, it's actually just re-emitted sunlight that is given off in the infrared, and we experience that as heat. Okay, so this energy coming down from the sunlight coming down from the sun, we see that moving down here, and then here we see that infrared radiation, which it says right here, is emitted by the Earth's surface. Now, some of that will go back out into space. So that infrared radiation will just travel back through the atmosphere and get sent out into space. A lot of it, though, gets reabsorbed by the atmosphere. And we'll go into why that actually happens, what's going on with the gases. But it's this trap, it's this trap right here where that infrared radiation is caught in the atmosphere that keeps the Earth's surface warm enough to live. Okay. The same thing happens with an actual greenhouse. Actual greenhouse is much warmer during winter or during cold times because the sunlight gets in and the infrared radiation is released. That's what we experience as heat, and that heat gets trapped in that actual greenhouse. Um, so the problem now is that we're putting more greenhouse gases into the atmosphere. The more greenhouse gases we have, the more we get the heat trapped. So the more greenhouse gases, the more of this process we get right here. More heat means the global temperature rises. Okay, so let's take a look at the actual greenhouse molecule. Okay, so these are a couple of the greenhouse gas molecules that we talk about. The big one is carbon dioxide. So we know that carbon dioxide is emitted when we burn fossil fuels. That's just a fact. Um, Extra carbon dioxide in the atmosphere increases that warming of the greenhouse effect. Carbon dioxide is a big one. Methane is a big one. We don't talk about that as much. Water vapor, which we're not really doing anything to contribute to more water vapor necessarily, and nitrous oxide. So a lot of these are pollutants. Carbon dioxide, nitrous oxides, and methane are all gases that we give off through various industrial means, through agriculture, things like that. Water vapor, we don't really have anything to do with water vapor as far as putting that into the atmosphere. However, as global temperatures rise, as they have been, what happens is you actually get more water vapor in the atmosphere. Because think about it, if it's hotter, the atmosphere is going to be able to hold more water vapor than if it was colder. So the more water vapor you get, the more greenhouse gases you have, the more warming you have. So that's a positive feedback loop. The more water vapor you have, the warmer it gets, the warmer it gets, the more water vapor you have. Um, But what happens with these molecules is each one of these molecules, and we'll focus on carbon dioxide because that's the one we normally talk about, um, they actually are going to absorb the, um, the infrared radiation, or what we experience as heat. They're going to absorb that as it bounces off or is emitted from the Earth's surface, right? So let's take a look at what a little animation of what that looks like. All right, what you see here is an animation, and it's showing a carbon dioxide molecule. And you can see the infrared radiation hitting the carbon dioxide molecule and then getting re-emitted. So the thing here is that the infrared radiation is actually coming up from the ground. When it's absorbed by the CO2 and then re-emitted, it could go in any direction. It could scatter in any direction. So some of it still scatters out into space, but some of it is directed back towards the ground. Some of it is directed horizontally through the atmosphere to hit other carbon dioxide molecules or other greenhouse gases. Um, when the infrared radiation actually hits the carbon dioxide molecule, you see it moving, right? And it actually vibrates. That vibration is coming from the extra energy in the infrared radiation. So the infrared radiation is giving a little bit of extra energy to that carbon dioxide molecule. It vibrates, but that's unstable. So it's going to re-emit that extra energy as more infrared radiation in a random direction. It's going to be, it could go anywhere. So it was going up towards space, hits the greenhouse gas, and then it could go in any direction. More of that infrared radiation is going to get trapped or directed back down towards the surface than if it had been allowed to go straight up into space. All the other greenhouse gases do the same thing. They're complex molecules like water vapor, methane, the nitrous oxides, the ones that we just looked at. And they're more complex than the smaller molecules like oxygen gas, which is O2, or nitrogen gas, which is N2. Nitrogen gas and oxygen gas are too simple and they don't absorb the infrared radiation. They're too small um, and infrared radiation just passes right through or right by them. Okay. All right. If you have more questions or want to go over this some more, just let me know. Thank you very much.